2025 Grade 6 Mathematics Performance Task. Welcome back to the channel, Pep Stars. In this video, we're going to look at the 2025 Mathematics Performance Task. And the title is Transportation. Let's read the scenario. Mr. Taylor has decided to get into the transportation business. He wants to buy a motor vehicle to take students and teachers to school. The schools are located in Bakertown. He has to decide whether to buy a bus or a car. The students and teachers live in Prime Estate, which is also located in Bakertown. Help Mr. Taylor to determine the actual distance between the different locations, calculate the actual number of trips that the bus and a car needs to make on a given day, calculate the amount of money that could be made daily from each vehicle, and recommend which of the two vehicles should he buy. Part 1, Bakertown. The diagrams represents the places located in Bakertown. And we see the primary school, high school, and prime estates. Question 1. Show the units on the map of Bakertown and their actual distances. For every unit given on the map, its actual distance is 100 meters. So 1 unit represents 100 meters. Examine table A carefully, then complete it by writing the appropriate units or meters and the blank spaces provided. Remember, 1 unit represents 100 meters. So the first two are done for us. And we can say 3 units, 300 meters, 6 units, 600 meters. 1,000 meters, 10 units. 20 meters, 2,000. 20 units, 2,000 meters, 30 units, 3,000 meters. Let's move on to the next information. Diagram 1 shows the map of Bakertown. There's also a key to help you to identify the symbols on the map. Or we can see the town here and the different symbols and labels and the keys for each square. That's 1 unit, and we can see what the road looks like. Let's look at question 2. For question 2A, B, and C, each row has a statement made about the map given in diagram 1. Place a tick under the appropriate heading to indicate whether the statement made is true or false. Remember to use the diagram to help you, and remember 100 meters is 1 kilometer. Both the primary school and the high school are both located on Main Street. Let's look. This is Main Street, and that's correct. Both of them are located on Main Street, so that's true. Mr. Taylor will drive less than 1,000 meters between the entrance of the high school and the entrance of the primary school. Let's look at the diagram. So remember, 1 unit is 100 meters, so 10 units need to be 1,000 meters. So let's check between both of the entrances. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, between the high school and the primary school, that's 1,000 meters. So therefore, this statement is false. So they said less than 1,000, and we counted exactly 1,000. Let's move on to 2C. If Mr. Taylor uses English Road to go from the entrance of Prime Estate to the entrance of the school, he will drive at least 1.6 km, and that should be 16 meters. So let's count it. Entrance of Prime Estate, 1, 2, 3, 4 along English Road, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, And we have 16 here to the entrance. So therefore, he will drive at least 1.6 kilometers. So this is true. Let's move on to the next question, part 2. Number of trips. Diagram 2 shows on average the number of trips made with full loads by each vehicle, car and bus in the day. Each trip is made between prime estates and the primary school. And a full load is when all the seats in the vehicle are occupied by passengers. So diagram 2 shows the bar graph with the number of full loads made by two vehicles at different time periods during the day. And we can look at the number of trips made by the car and by the bus with full loads. We're going to analyze this later when we're doing the questions. So question 3 says, based on the graph, what is the total number of trips made with a full load by the car and the bus in the day between primary state and the primary school? So when we look at the label, the car is blue and the bus is yellow. So there are 6 trips between 6 a.m. and 8 a.m. So let's write that down. And for 8 to 10, we have 3 trips with full load. So we'll add on the 3. And for 2 p.m. to 4 p.m., that's 6 again. And from 4 p.m. to 6 p.m., that's 5 full trips. So let's add another 6 and 5. So let's do the calculation. So that is 20 full trips. 20 full loads. And let's do it for the bus now. Upstairs. Okay. Wait. Let's look at the bus now. From from 6 to 8, 2, 8 to 10, 1, that's 3. 2 p.m. to 4 p.m., that's another 2, that's 5 full loads. Plus 1 from 4 p.m. to 6 p.m., so that's 6 full loads. Let's get right the 6 because I already calculated. In your working out, you can extend. You should have extended, but for the purpose of the review, I'll just write the answer. So a full load for a car is when 4 passengers are seated, and the ratio of the number of teachers to the number of students traveling in the car that has a full load is 1 to 3. Diagram 3 shows the total number of teachers labeled T and the total number of students labeled S that traveled in a car that has a full load. And we can see the teacher at the front and 3 students at the back. So that's the 1 to 3 ratio. And that's a total of 4 passengers. So now let's look at the bus. A full load for the bus is when 14 passengers are seated, and the ratio for the number of teachers to the number of students traveling in the bus that has a full load is 1 to 6. What is the total number of teachers and students traveling in a bus that has a full load? So remember to use the ratio given above, and we'll write the response on each seat in the bus below. So on each seat in the bus below, write T to represent each of the teachers and S to represent each of the students. Then in the box provided, fill the total number of teachers and the total number of students. So because it's a 1 to 6 ratio and there are 14 passengers, we can say, think about two numbers that when you add them together, you'll get 14. And these two numbers also have to be divided by 1 and 6. So when I thought about it, let's put by the ratio here. I thought about the two numbers 2 and 12. So if you had 2 teachers and 12 students, if you reduce 2, 22 goes one time, and 12 goes 6 times. So you'd have gotten the same 1 to 6. So I can say there are 2 teachers and 12 students. So I'm writing the S for the students. And I will say the number of teachers, 2 teachers, and 12 students, and this will give me a total of 14 passengers. All right, now let's move on to number 4. What is the total number of passengers, teachers, and students that would have traveled by the car for the entire day? So when we go back to number 3A, we saw the total number of cars was 20 full loads, and for the bus 6 full loads. And we know that there were 1 teacher in there's 1 teacher per load, and there were 20 full loads, so therefore it's 1 times 20 gives you 20 teachers, and for each full load of car there's 3 students, so 3 times 20 gives you 60 students, and 20 plus 60, that's a total of 80 passengers. For the bus, for a full load for the bus, there's 2 teachers and there were six full loads, so 2 times 12, 2 times 6 are equals 12. And for students, there are 12 students per each full load of trip for the bus. And therefore, if you have six full loads, then that's 12 times 6, which is 72, and 72 plus 12 is 84. So that's 84 total passengers. So based on your response, correctly complete the sentence by giving writing bus or car on the line. So on average, the bus takes more passengers on a given day than the car. Let's move on to part 3, the amount of money to be made. The fare that Mr. Taylor will collect for each teacher and for each student is given below. So for each teacher, that's 64.50 for a kilometer, and for students, it's $96 point 65 for a flat rate, and flat rate means that the cost will remain the same no matter the distance traveled. So the distance from the entrance of Prime Estate to the entrance of the primary school is 30 units on the map of Bakerstown. Calculate the fare traveled from Prime Estate to the primary school for one teacher. So for one teacher, if it's 64.50 per kilometer, we have to find out how many kilometers. So there's 30 units. So that's 3,000 meters or 3 kilometers. Let's look back at the ratio that the unit that we were given before. Let me just double check that it's correct. So one unit is, let's go back to the initial. One unit represents 100 meters. So 30 units is 3,000 meters. So we got it correct. And 3,000 meters is 3 kilometers. So I'm just writing this out so I'm clear on what my calculation should be. I should have typed instead of written. But it's okay. You get the notion. So now I'd have to do 64.50 times 3. And that is 193.5. But it said to, let me see. Alright, so the fare for one teacher would be 193.5 or 0.50. Alright, so on the line provided, write the fare for one teacher to the nearest hundred. So 193 round off to the near hundred. So it's past nine. If we look at the digit in the tens place, it's past five, so we can round up to 200. Because they said the nearest $100, so that's 200. And the fare for one student is 96.65. So on the line provided, right, the fare for the student to the nearest 196. Again, we're looking at the ones place, and then we can round 96 up now. Or from it's greater than 50, we're actually rounding the number up to 100. So based on our responses to the final question, we will have to make the recommendation now. So based on our responses in question 4 and 5B and 5C, what is the total amount of money that Mr. Taylor will make in an entire day with each vehicle? Alright, so not the recommendation yet, but the total to make the recommendation. So for the car, the total money that Mr. Taylor would make, we have to go and look back at how many students. 60 students for the car, 20 teachers for the car. So let's work out the car first. 20 teachers and 60 students. Gonna just put T for teachers and put S for students. So it says based on the answer in 5C, so we're actually using the rounded version then. So it says based on these answers, so we're using 200 and 100 now. So 20 teacher times $200. That would be 4,000. And 60 students times $100, that would be $6,000. So in total for the car, Mr. Taylor would have made $10,000 for the day. And now let's calculate the bus. So we go back and look back at how many teachers and students there were for the bus. For the students, there were 72 students and 12 teachers. That's 12 and 72. So 72 times 100, that's 7,200. And 200 times 12, that's 2,400. And that would have been 9,600. So for the bus, Mr. Taylor would have made 9,600 for the day. So based on your responses throughout the task, which vehicle should Mr. Taylor buy, car, bus, and use your calculations if needed to explain your recommendations. In the space provided, explain why you have recommended the car or bus, then tick the box for the vehicle you have chosen. So we can recommend the car because overall the car would carry, even though it does carry more passengers, based on the cost, it carries more teachers and the teachers will pay more, and hence Mr. Taylor would be able to make more trips per day based on even the bar chart, and therefore make more money for the day. So we can just write that down. The car makes more trips per day and takes more teachers that pay more than the students. Therefore, the total amount of money Mr. Taylor would make for each day would be more if he was to purchase the bus. And you kind of say that he would make 10,000 each day from the car and 9,000. What was the cost again? 9,600 for the bus. 9,600 for the bus. Alright, so you can rephrase it the way you want to. I just chose to write it this way. So there you have it. That's the 2025 Mathematics Performance Task Paper Review. We're gonna begin our CBT practice shortly, so you also want to stay tuned for those videos.